So up to now, we've mostly been assuming that circular motion occurs at constant speed, which is called uniform circular motion. But of course, this isn't necessarily the case. Sometimes circular motion occurs while the object is also speeding up or slowing down. So imagine like something starts moving in circular motion really slowly, and then it gradually speeds up and moves faster and faster and faster as time goes on. How do you handle that situation? Or what do the variables of motion look like for that situation? So I've drawn a picture in the top right corner of the slide there where an object is moving counterclockwise in a circle. Its velocity vector is, of course, tangent to that circle, and it has a centripetal acceleration towards the center of the circle. That we already know. That is true regardless of whether the object is moving at constant speed or not at constant speed. So one thing I want to say right off the top here, centripetal acceleration is present whether or not the object is moving at constant speed. So the centripetal acceleration is there regardless. But if the object is not, well, let me say it this way. If the object is moving at constant speed, centripetal acceleration is the only acceleration. But if the speed isn't constant, there is another acceleration in addition to centripetal acceleration. So that's the first thing to understand. Centripetal acceleration just tells you that the object is moving in a circle. There is another part of the acceleration which tells you whether the object is speeding up, slowing down, or remaining at the same speed. So this other component of acceleration is called the tangential acceleration. So tangential acceleration tells you whether the object is speeding up, slowing down, or staying at constant speed. Okay, so what is the direction of the centripetal, of the tangential acceleration? This you can actually probably guess if you really mastered the content from translational motion section of the course. Namely, remember that acceleration in the same direction as velocity is what causes a speed up, and acceleration opposite the direction of the velocity causes a slowdown. The same thing is true here. Obviously, from the name, you can tell that tangential acceleration is going to be tangent to the circle, just like how velocity is tangent to the circle. So there are basically three possibilities. Okay, so let me say this first of all. So tangential acceleration is tangent to the circle, obviously. So you can have three possibilities. Possibility number one, it could be in the same direction as v. So this will cause a speed up. It could be opposite direction as v, and this will be a slowdown. Or it could be 0, and this means constant speed. But notice the acceleration still doesn't equal 0, only the tangential acceleration equals 0. So like, for instance, in my picture up here, if the tangential acceleration points this way, let me get a different color. What haven't I used yet? How about green? If the tangential acceleration points this way, that would mean the object is speeding up. If the tangential acceleration points that way, that would mean the object is slowing down. And if the tangential acceleration is absent, that would mean the object is traveling at constant speed. Okay. change the color of my text instead of my arrow. Anyways, so that's how you handle tangential acceleration. So like, let's say, for example, we had here a tangential acceleration pointed in that direction. Tangential acceleration, as you can probably guess, is going to be denoted as AT. Tangential acceleration would be opposite direction of velocity. So this would describe an object which is traveling counterclockwise, but slowing down as it travels counterclockwise. The tangential acceleration has an angular equivalent. So there's also an angular variable that gives you the same info as tangential acceleration, and that is the angular acceleration, alpha, which I mentioned briefly in one of the earlier videos, I think. So the angular acceleration has the same idea, where if the angular acceleration is in the same direction as the angular velocity, that's a speed up. If it's 0, that's constant velocity, and constant angular velocity. And if it's in the opposite direction from angular velocity, that would be a slow down. So you can describe how the speed of the object is changing either by giving the tangential acceleration or by giving the angular acceleration.